All right, in this segment, I'm going to show you how to solve a limit numerically. Now, numerically basically means what we've done in the last few examples anyway. It's where you create a table of values by identifying the numbers that are approaching your number from one of the sides, and then plugging those numbers into the function in order to get all the output values, and then you want to see what the output values are approaching. So to solve this limit, so we have the limit of x squared minus 4 over x minus 2 as x approaches 2 from the right, okay? And so in order to solve this numerically, we want to create a table of values, okay? We're going to have our x's, and then we're going to have our output values, which is our y values. Now we need to put maybe 3 values here that are approaching 2 from the right. That means that they are larger than 2. So let's say we'll have 2.1, 2.01, and 2.001, okay? Now what we're going to need to do is we're going to need to grab a calculator. So if you have a calculator, all right, I've got a calculator right here. And so what I'm going to do is, to find my output value for 2.1, I have to plug in 2.1 in here for the x here and for the x here. Okay, so if I plug 2.1 in there, I get 2.1 squared minus 4. Okay, that's going to give me 0.41 up here. So I'll just kind of put over here 0.41 divided by 2.1 minus 2. And that's going to give me 0.1. So now all I have to do is put 0.41 divided by 0.1, and that gives me 4.1. So this one's going to be 4.1, okay? Now I'm going to have to do the exact same thing for 2.01. So I'm going to do 2.01 squared minus 4, and I get 0.0401, okay? So I'll have 0.0401 divided by 2.01 minus 2 is 0.01. So now I just have to do 0.0401 divided by 0.01, and that's going to give me 4.01. So that means this one's going to be 4.01. And now I'm going to plug in 2.01. So 2.001. I'm going to square it and subtract 4. That gives me 0.04001 divided by 2.001 minus 2 is 0.001. All right, and when I put that in the calculator, I get 4.001. 4.001. So all I'm doing is I'm identifying some x values that are approaching this number from this direction. Then I plug each of those numbers and solve for each one of them in whatever my function is. So I get a bunch of output values. So we can see here that x is approaching 2 from the right, right? Okay. Well, what is y approaching here? 4.1, then 4.01, then 4.001. It looks to me like y is approaching 4. And therefore, the answer to our limit is going to be 4. And that is how you solve a limit numerically with a calculator. Now I'm going to show you how to do it with Desmos. We're going to break now, and we're going to go into Desmos, and I'll show you how to solve a couple of limits.
All right, so we're going to use Desmos to solve a limit numerically. We're going to create a table of values in Desmos, so we will not need the graphing area over here. We're going to do everything over in this part of Desmos. So here is a situation, whoops, there we go. So here's a limit problem. So we have the limit of this crazy looking function as x approaches -7 from the left. Okay, so we need numbers that are smaller than -7, like -7.1, -7.01, etc. So now we're going to go back to Desmos here. And the first thing that we're going to do is we're going to put in the function. We're going to put y is equal to, and Desmos has some pretty neat features. It'll give you a fraction if you just do like 2 divided by 3. It'll give you a fraction. Now on the top here, we want to put, well wait, the bottom was x squared, so I can do x caret 2, so that's x squared minus 49. And then if I go back to here, x squared minus 7x minus 98. Okay, so we're going to put x squared minus 7x minus 98. Let me make sure that I got that right. Yeah, all minuses there. Okay, good. Now we don't have to put in the limit. All we're doing is putting in the function itself. Okay. All right, so now I'm going to go back to Desmos, and what I need is I need to make a copy of this. I don't know if you know this. Desmos will make a copy of one of these entries for you. If you go up here to the gear, hit Edit List, and then if you hit this button right here, Duplicate, it'll make another one of them. Now we're going to use this right here. This says Convert to Table. So what it's going to do is it's going to convert this entire function into a table. And so now we have a table that we can use for entering data. Now I don't need the ones they gave me. I'm going to use different ones. So I'm going to delete all these here. Okay. And we're just going to now type in our numbers that are approaching -7. So, and we're approaching from the smaller side of -7. So like I said, we'll put in, let's say, -7.1. Then -7.01. Now I want to show you, look how Desmos is populating the answers for you. You don't have to calculate it. Desmos will do it for you. And then -7.001. We can even throw another one in. How about -7.0001? And you can see here, now what we can do is we can just look at our output values and we can see what are they approaching. As our x value approaches -7, what are the output values approaching? Well, we've got 1.496, then 1.4996, then 1.49996, then 1.499996. Okay, it looks to me like we are getting closer and closer here to a decimal value of 1.5, because we're getting closer. This 0.496, 0.4996, 0.49996. 0.499996. This 0.49 is getting closer to 0.5. The 1 is not changing at all. And therefore, I'm going to go ahead and say that the answer to this limit problem is 1.5. Okay? And we used Desmos to find that.
Now, I recommend solving limits numerically with a calculator or with Desmos anytime that you're going to, anytime you come up on a weird situation where it's difficult to solve the limit analytically or graphically. Now, in the next couple segments, we're gonna learn how to solve them from graphs, and we're also going to learn how to solve them analytically using algebra. But if you ever get in a situation where you say, man, I've been working so hard, diligently, so hard on this problem, and I just can't find the answer, you can always fall back on just grabbing a calculator, creating a table of values, and seeing where the limit goes. Okay, so here's a great example. This is probably a well-known problem within the world of calculus. What is the limit as x approaches 0 from the left side of the absolute value of x divided by x? Okay, so because this is sort of a weird problem, it's a great one to do using a table of values, doing it numerically. So I'm going to go grab a calculator. I'll be right back. All right, so the first thing I need to do is I need to put in some x values that are approaching 0 from the left. So they have to be smaller than 0, right? So that means they have to be negative values, because any number smaller than 0 is a negative value, okay? So let's do maybe negative 0.003, negative 0.002, and negative 0.001. So we're getting closer and closer to 0 here. This is farther from 0 than this, and this is farther than 0 to 0 than this, and then this is right next to 0. So we're approaching 0 from the negative side, right? All right, so what we're going to do is we're going to plug these numbers into the function, and actually we don't really need a calculator for this, but we'll use one anyways. Okay, so I'm using a calculator, and it says I want to do the absolute value of x. Well, what's the absolute value of negative 0.003? Well, that's just 0.003, right? 0.003 divided by, and then I'm just going to put negative 0.003 in the denominator, so divided by negative 0.003, and that gives me negative 1. So I'm going to put a negative 1 here. Now I'm going to do the same thing here. The absolute value of negative 0.002 is going to be positive 0.002 divided by, and now in here I'm just going to put negative 0.002. All right, and that gives me negative 1 again. Oh, that's weird. Okay, well, calm down. Don't freak out. I'm going to explain all this to you in just a minute. Now I'm going to put in negative 0.001. I'm going to put it here and here. The absolute value of negative 0.001 is 0.001 divided by negative 0.001, and that gives me negative 1. So I'm going to put a negative 1 here. And so now this is a little weird because normally what we see is we see a changing number, but here we don't see a changing number. It's just negative 1, negative 1, negative 1. Well, guess what? When that happens, if you keep getting the same number in the y column, then that is your answer right there. So what this value is approaching, it's negative 1, and then it becomes negative 1, and then it becomes negative 1. What do you expect it to be next? Probably negative 1. Therefore, the answer to this is negative 1. As x approaches 0 from the left of this function, the answer is going to be negative 1. Okay? All right. So now let's try one on the positive side of 0. And so we have the limit of 1 over x as x approaches 0 from the positive side. Okay? So why don't we this time, why don't we do point, so they have to be positive numbers, so they have to be larger than 0. So we can use the same ones we used last time, only not positive. So we can do 0.003, 0.002, and 0.001. You could also use 0.1, 0.01, and 0.001. That's fine. Okay, as long as your numbers are getting closer to 0 on the positive side. Okay. All right. So what I want you to do now is, why don't you grab a calculator and identify the 3 y values that go along with these 3 x values, and then we'll identify the limit. All right, so the first one's going to be 1 divided by 0.003. So 1 divided by 0.003 is 333.33. Okay. Now we're going to do 1 divided by 0.002, and we get 500. Oh boy. That doesn't look helpful. Then we'll do 1 divided by 0.001. Oh, I didn't put a decimal there. Okay, and we get 1,000. Okay. All right, so here's a great example. Look what's happening here. The numbers are not getting close to anything in particular. In fact, the gaps between the numbers are getting large. We went from 333 to 500. Okay. That's an increase of about 167. But then we went from 500 up to 1,000. That's an increase of 500. Y is not getting incrementally closer to anything. The numbers are just getting larger and larger and larger. This indicates to me that I think what we're dealing with is a limit at infinity, that the answer is probably infinity or does not exist. But just to make sure, let's go ahead and throw one more in here. How about a 0.0001 and see what happens? 1 divided by 0.0001, and we get 10,000. Sure enough, we have these ginormous jumps in values as we get closer and closer to 0, which leads me to believe that there is a vertical asymptote, and I can show with certainty that there's a vertical asymptote. If we were to put 0 in here for the x, we would have 1 over 0, sure enough indicating a vertical asymptote on this function at 0. And that explains why the values are getting larger and larger and larger. So what we would say is that the limit of this function as x approaches 0 from the left is, we can either say that the limit is infinity, or we can just simply say DNE for does not exist. Okay? All right, now we're going to switch over to the computer in the next segment, and we're going to see how to solve limits when we're given a graph instead of analytical limits.